Okay, so for problems like this, remember, whenever we're told as a mean score and a standard deviation, and we're asked to find, what percent is between these numbers or less than or greater than, what we're looking at, they're superior, good deal. And what we're looking at is a bell curve. Normal distribution, and the word we're looking for here is the empirical rule.
So are you reviewing from our homework, I hope?
Yes.
Okay, good.
So remember, if we're looking at that, the mean is in the center. So that's the 83. And we go out in steps of one standard deviation at a time. So the standard deviation is 6. This would be 77, 71, and 65. Going this way, it would be 89, 95, and 101. And the percents, 34.13% in each of these, 13.59 in each of these, 2.15 here, and here, and 0.13 on each of the outside tails. Now remember, these percents here are constant. They never change. What changes are these numbers down here depending on the mean and the standard deviation for our set of numbers. So for question 1 there, it's asking less than 77. Well, here's 77. Less than would be off to this side. So we're just going to add up those percents. If we add up 0.13, 2.15, and 13.59, we should get 15.87%. So we would expect 15.87% to score less than 77. For the next one, greater than 95. Here's 95. Greater than would be over here. So we're going to add those two percents. 2.15 and 0.13 gives us 2.28% that we would expect to score greater than 95. Between 77 and 89, so that's here and here, we add those two percents together, 34.13 and another 34.13, we get 68.26%. And finally, less than 89. Here's 89, and less than would be all these percents. So we add them all up. Should add up to 84.13%. Any questions? Is that looking familiar to everybody?
Sure does.
Good. Well, there's that blank page syndrome, right? When you're sitting there by yourself, it doesn't seem to want to come back. There's actually been a lot of psychological studies done that the setting that you learn the material in is where you remember it the best as well. They've had students that were struggling to do their homework actually go sit in the room where they had their lecture, and they do a better job on their homework sitting in that room than they do sitting at home. Okay, are there any other questions from the homework from last week?
You know, I did have a little bit of a question. It seemed like what we talked about in class when they were asking questions in the math lab, they would be like, hey, what's the variance of blah, 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 and I wouldn't understand what they were talking about, so then I would test out, so I was wondering if you could go over, like, again, like there's that 6-step process, but it's like, at what point, I was just wondering if your terminology was the same as the book, and if I was supposed to go back and...
So, Margie, what is the difference between when and both the standard deviation
Okay.
and the way that you give us standard deviation.
Okay. The way the book does the standard deviation is just a formula, but the result ends up being the same way. So let's go through it step by step and we'll put names on it. Remember, the variance is just what you get at the end of the 5th step, and the standard deviation is the end of the 6th step. So let's just put out a set of numbers here. We'll go 5, and I'm going to put them in order just to make it easy on me. 5, 11, 13, 16, and 25. So for this set, n equals what?
5.
5, because there's 5 numbers. So what is our first step?
The first thing we do is to find the mean.
Find the mean. Very well. 5 plus 11 is 16, plus 13 is 29, plus 16 is 45, plus 25 is 70. Divided by 5 should be 14 is our mean. I'll pause to let you guys verify that. Is that correct? What's step 2?
Now you can subtract that mean from each of the numbers. And so is that what's called deviations?
Yes, these are the deviations.
Okay.
So we're going to subtract the mean from each number. So our numbers 5, 11, 13, 16, and 25. I'm going to erase and give myself a little more room here. We are going to subtract the mean from each of those. So we will subtract 14. 5 minus 14 is a negative 9. 11 minus 14 is a negative 3. 13 minus 14 is a negative 1. 16 minus 14 is 2. 25 minus 14 is 11. I almost wrote 9 there for a second. These right here are called the deviations. And remember, if you added them up, the sum should equal 0. Step 3 is what?
Square them.
Square each deviation. So negative 9 squared is 81.
81.
Negative 3 squared is
9.
9. Negative 1 squared.
1.
And 2 squared.
4.
4 and 11 squared. 121. Very good. These are what are called the squared deviations. What's step 4?
Add the deviations together.
Find the total, yes. Yep, find the total of the squared deviations. The total here, if I add those all up, is what? 90, 125, 315, 316, I believe. That is what is often referred to as the sum of the squared deviations. I should label that as step 4. So that was step 4. What is
step 5?
Nope, that was step 4.
Oh.
Step 5 is the big one. What is step 5?
N minus 1 divided by the amount. Divided by the total, yeah?
Divide by n minus 1, yes. And since n we said equals 5, n minus 1 equals 4. So we divide by 4, which is going to be what, 79? That number right there is the variance. Step 6. Square root. Square root of 79. 8.888. Yep. 889 we'll round it off to. That number right there is the standard deviation. Does that make more sense now?
Absolutely. Yep.
Good. Any other questions off the homework? Or anything from last week? As you saw, we did go a little bit past the homework. The homework doesn't go so far into probability as we did. But I think that contingency table probability is important to know. Okay, well then today we finished up our statistics. Our business statistics is behind us until we get to our unit test. Unfortunately, I just looked at the schedule here today and realized that the schedule really sucks for you guys this semester because we have lecture this week and lecture next week. Then we go on spring break, and then we get to come back, and the class after spring break is our Unit 2 test. So you can think of it one of two ways. Either that gives you all of spring break to study for the test, or that gives you an extra week to forget everything for the test. One of the two. But you do have, just to warn you to be looking ahead, that we do have that scheduling issue this semester, that your first class back after spring break is going to be your Unit 2 test. I didn't do that on purpose, I swear. So today we start our merchandising section. And in merchandising, there are two things, or two branches that we're going to look at. We have some sort of either manufacturer or distributor sometimes referred as a generic term as just a supplier. This person, or this entity, if you want to look at it that way, either they create the goods or they acquire the goods and pass them along to the next level, which is a retailer. The retailer does not actually produce anything. They're just taking the goods from that manufacturer and taking them to the customer. So they are, the retailer is the link to the final customer. This week, we are going to look at this relationship here, from the manufacturer or distributor to that retailer. Now, some retailers are also distributors. The difference is this distributor here never has direct contact with the customer. There's always some other business between them and a customer. So anyway, the manufacturer to a retailer, supplier to a retailer. First thing we're going to look at is something called a trade discount. Most suppliers do have outlet stores. And you know, there's a big one over here in Minnesota at North Branch. You go over there and they sell you at reduced prices direct to the customer. Well, if you can go in there and buy it for that price, why would some other store ever purchase it? Well, because they get a trade discount. Because they are a retailer and because the supplier is assuming they're going to buy more than your average customer, individual customer is going to do, they're going to get a discount. And that is called a trade discount. For example, you might get a 4% trade discount just for being a business. Now, there are qualifications that they set that you have to make for being a business. Sometimes you have to have just an established state and federal identification as a business account. Other times you have to have a certain volume. You have to have a certain volume of sales in a year. Sometimes it's a certain volume of sales in their products for the year. So you can't just apply and get, you know, a LLC under your name and make yourself into a business and get these discounts. There are qualifications that you have to meet. So let's say you get that, you own a business and you get that 4% trade discount. So let's say you have items with list price. List price is that standard price that anybody off the street can come in and buy it for, of $1,400 will cost you how much? Well, now if you remember back in our first unit here, we talked about these percent increase and decrease problems. This is a percent decrease problem. We have the list price here. From that list price, you're going to subtract your trade discount. And then you're going to get the price you pay. The price that you pay, we're going to call that the invoice price. That is the actual amount that is going to go on the invoice that the supplier sends to you or puts in your records. And as we mentioned before, each of these numbers in a percent problem is going to be described by a percent and by some other number. And in this case, that other number is dollars. So we have the 4% trade discount. That's going to go in here. We have the $1,400 list price. We want to know what it's going to cost you. That's this number here. That looks like that's all we know, but what else do we really know? Well, whenever we're dealing with percents, something is 100%. Most of the time, that is either the whole amount or the beginning amount. The beginning amount here is the list price. So that's 100%. If there's a 4% discount, 100 minus 4 is 96% is the invoice price. So we are looking for this amount here, which means we don't really need this line, so I'm going to ignore it. So we can cross multiply and divide right in our table. 96 times 1,400 divided by 100 is 1,344. So it will cost you, after your trade discount, $1,344 to purchase that merchandise. Now in business, this trade discount occurs often enough that we come up with shortcuts. We had mentioned something when we talked about percents originally, something called the rate method of percents. That rate method of percents was turning the percent into a decimal and multiplying. And we had mentioned that only works well when we're going from the whole amount to that piece that is represented by the percent. Well, in here we have a 4% trade discount. We have to use something called the complement, which is a really complicated word for a fairly simple concept. It's what we did up here. If there's a 4% discount, what percent are we left to pay? 96%. Complements are just two things that add up to the whole thing. In other words, two things that add up to 100%. So if we have a 4% trade discount, that means we pay 96%. The complement. In other words, 100 minus 4 gives us that 96.
So hold on, who gets the trade discount? The company or the customer?
Well, remember, we're not dealing directly with the customer right now. We're dealing, you have the manufacturer and then you have the retailer. The retailer is buying from the manufacturer, and that retailer gets the trade discount.
Okay. And the outlet is the retailer, or the outlet is company?
The outlet would be the retailer. Ignore what we said about outlets. The outlet is a way of surpassing the retailer. It's direct from the manufacturer to the customer. This is going through the standard chain where you have the manufacturer sends to a retailer and the retailer sells to the customer.
Okay.
So we have 96%, which would be a rate of 0.96. So that $1,400 price multiplied by that 0.96 should give us $1,344. And there it is. So there's our $1,344 price. That is the invoice price. Yeah. There's a reason why I'm doing it as a decimal, as we'll see in just a few minutes. Now, a lot of these places will offer incentives. So if during one quarter you have a certain amount of purchases, you buy a certain volume of merchandise from them, they'll increase your trade discount. So let's say you met that volume level, that threshold, and they might have several of them. Let's say you met the threshold so that over this next term, you are now going to receive an 11% trade discount. So in your notes, how much do you pay for merchandise with list price of $860? So go ahead and figure that out for me quick. So some of you might be doubting your answer right now because that first example I did a really long-winded explanation for a relatively simple calculation. What is our trade discount here? 11%, yes. We need the complement of that, which is what?
89.
You got it. 100 minus 11 gives us 89%. So all we have to do is take that list price, $860, multiply by 0.89, which is the 89% as a rate. $765.40. How many of you had that? Okay. I was just a little short of time. Okay. Anybody not sure how we got that wants me to go back over it? Okay.
What is the difference between the list price and the invoice price?
The list price is what they would charge. Where is it here? List price is what they would charge to anybody coming in off the street. So let's say you just start up a business and you want to start buying from them. They're most likely going to charge you that list price until you establish as a retailer. And then as you establish your business, they'll start to slowly give you that trade discount.
So you get the list price initially, and then you earn the trade discount.
In many cases, yes. Some cases, once, yeah. What's that?
I don't mean to interrupt.
No, you're okay.
They incentivize you.
Yeah, pretty much. In fact, I'm glad you brought up that word of incentives, because a lot of manufacturers do that. They'll have incentives, whether it is, what we did here, you met a sales goal or you met a volume goal, and so they increased your trade discount from 4% to 11%. Sometimes, though, rather than, oops, go ahead.
Go ahead.
Sometimes,
Do you have to make a certain amount in order for them to increase that trade discount?
Sometimes they might have other requirements that you have. Maybe you have to buy a certain product, or maybe you have to move a certain amount of this product, or you have to buy products in so many different categories, or whatever. Whatever their requirements are to make that incentive. Sometimes, though, and rather than just increasing your percentage, they stack them. So let's say that you receive a standard 6% discount, 6% trade discount, just for being a retailer. And let's say you met your sales incentives last quarter, so they're going to give you an additional 5% discount for an incentive. Now,
it's almost like being a used car salesman and making a better commission if
Yep.
you sell a certain amount of cars.
Exactly. Now, let's say that they have a new product that they want to get out there, so they're going to give you an additional discount if you buy some of that product. So let's say they're going to give you an additional 11% discount for that product. I'm just going to call that a special discount. All of these actually qualify as trade discounts. Like I said, usually the first one is a discount you get because you're a retailer, because you're established with that supplier, that manufacturer. The other discounts often have special circumstances. Like we said, you met sales goals, or you're buying special products, or whatever reason that company might have for giving you those additional percents. Now, the way this works, it would make sense if you just added them up and got 22%, wouldn't it? It doesn't work that way, though. The way it works is this. In fact, the way this would be listed as a trade discount, the notation would be listed as this: 6/5/11 trade discount. Exactly. In fact, it is sometimes referred to as a chain trade discount.
This might be way off the subject, but how come at the end of the season, like when I can get something for 90% off, how do they make any money?
That's a bigger question that we'll come back to later.
Okay.
Well, that deals with spoilage and stuff like that. They're actually losing money on that, but that's built into their markups. That's actually something that we cover next week.
Oh, very cool.
So anyway, that chain trade discount is just several trade discounts applied at once. And the way you would work that, let's say that we are going to purchase merchandise with list price of $4,200. How do we find, one, our invoiced amount, and two, the amount of our trade discount? Based off of this chain discount, 6511 as it's listed there, there are some numbers we can find. So we are going to define a net decimal equivalent. Sometimes referred to as a net price equivalency. Varying on what textbook you're looking at or what company you're working for, there are slight different names. Notice both of these names have the word net in them. This is a rate that is used to find the net price. The net price is your invoiced amount. It's your price after discounts. That net price equivalency rate is found from our chain discount by using the complements and the rates. And I'm going to kind of do two steps in one here. 6% discount means we're paying what percent? 94%. So I'm going to write that as a rate, 0.94. So I'm going to stop. Any question as to where that 0.94 came from? From the 6. Okay, so 100 minus 6 is 94, and we turn it into a decimal. 5% discount means we're going to pay 95, so that's 0.95. And 11% discount means we pay 89, so 0.89. Perfect. If we multiply those three rates, 0.94 times 0.95 times 0.89, we will get 0.79477. That is that net decimal equivalent or net price equivalency rate. That number there is used to find the net price, as we said, the invoiced amount. So we had $4,200 as our list price. We're going to multiply that by the NDE, that's the net decimal equivalent. So we're going to multiply that by 0.79477. Is 338.03, or 3338.03, I should say. That there is the net price, or the invoice amount. Any questions? It is. We're going to do several examples. It'll get better with repetition, hopefully. The other number we can find from that, the other rate, is called the single discount equivalent. Sometimes called the single equivalent discount rate. Doesn't matter. We're going to refer to that as the SDE, single discount equivalent. This is found by taking that net decimal equivalent and subtracting it from 1. So our net decimal equivalent here was the 0.79477. 1 minus 0.79477 is 0.20523. That is that single discount equivalent. Notice, by the way, these two numbers add up to what? 1, which would be 100%, right?
You really need to use that many decimals in that answer?
Yes, go up to 6 decimal places for these. My math lab will might tell you otherwise, but unless you are told to go up to 6 decimal places. This is used, the single equivalent discount, or single discount equivalent, is used to find the dollar amount of the trade discount. So to find the dollar amount of the trade discount, I'm going to take the list price times that SDE. So my list price was the 4,200 yet, times 0.20523, and we get, I believe, $861.97.
So I was wondering, at my job, like I do bulk mailing, and your regular mail is like 49 cents, and so when you do all these things, it's like, 0.1735, whatever, with these big long numbers, is that sort of that, same sort of thing?
Yes.
Like, and my second question is, why is it so many, why don't they just say, it's 18 cents, but it's 18 cents point blah, 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 why
Yeah.
all this big number?
There's actually some long formulas that go into calculating that percentage that's now it's 0.18 blah 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 blah, as you're saying. For the bulk mailing formulas, and I don't remember what they are right now, I've seen them before. The discounts on bulk mailing formulas are really very complex, because it goes, if there's more than a certain number of letters going to the same postal code, if there's more than a certain number of letters going to the same codes with the same first 3 digits, and those formulas are very complicated, and what the discounts are for meeting each of those different qualifications and stuff. But that's what it is. It's actually percentage formulas, and they're using a thing like this. Actually, they're using a net decimal equivalent based off the regular postal rate, and they're multiplying that regular postal rate by a net decimal equivalent. So there's a discount for having more than so many letters. There's a discount if they're all going to the same postal code, a somewhat smaller discount if they're going to postal codes with the same first 3 digits, and so on.
So do they have these big numbers so that you get a couple extra cents, as opposed to just rounding up? Or?
Pretty much.
Okay.
Yeah, they could round it down to the nearest penny, and it would cost them. I've seen the numbers on this and interest calculations and stuff like that. It's literally millions of dollars a year lost and gained in round off errors. Now, one thing you should note, this is the dollar amount of the trade discount. This is the net price, or the invoiced amount. Those two amounts better add up to the list price. So let's do another example where we can do this all at one shot and not have to insert the explanations as we go. So let's say that MPL Corp receives a 7/12/3 chain trade discount. I'm going to pause for a second here. That notation, by the way, if those numbers are right, can look very, very much like a date. So be really careful. That notation with a number / another number gets used a lot. In fact, it gets used for like 3 different things in this unit alone. So be very careful. It's the context that it's written in that tells you what it is. The word trade discount will appear somewhere near this, either right before or right after this. So we know that is a trade discount or a chain trade discount. So they purchase, we're just going to say items listed for $8,500. Find 1, their net price, 2, the dollar amount of their trade discount. So we start with that chain discount, trade discount of 7/12/3. What are we going to do with it? So 7, yes, 100 minus 7 is 93. So that becomes 0.93. 100 minus 12 is 88, so that becomes 0.88. Good. And 100 minus 3 is 97, so that becomes 0.97. We multiply those, 0.93 times 0.88 times 0.97, and we get 0.793848. What's that called? What's that amount called? Yes, it is the NDE is fine, net decimal equivalent. And that's used to find what?
Normal discount, right?
That's used to find net price. The word net is your connection there. Net decimal equivalent finds the net price. So we can find the net price off of that. It's going to be $8,500. And that's our list price times the 0.793848. $67.47.71. That's our net price. But wait, there's more. To find the discount, now I realize we could just take 8,500 and subtract. But we're going to go the long way so that we can use that as a double check. To find the discount, we're going to find that single discount equivalent. And we find that by doing 1 minus the net decimal equivalent, 793848, which is going to give us 0.206152. That is our single discount equivalent. What do we use that for? The dollar amount of the trade discount. So that's our list price again of $8,500 times 0.206152, which is going to give us $1,752.29. I hope. Am I correct? You guys can't trust me that much this late at night.
Thursday, 1752.29, right?
Yep.
Okay.
That's right?
Yep.
Okay, cool. So what do you think?
Okay.
Good stuff? Well, I think it
You
is...
just made this all up to torment us.
Oh, I could do way worse than that. What's that? Yes. Okay. It is 6:21, so it's time for our first break. So let's take our first break. We'll come back at 6:31.